Okay, we're going to have a few videos on solving systems of equations, linear systems, meaning straight lines. The first method is by graphing. So you have these two slope-intercept forms, and you're going to graph each one. So I'm going to graph this top one. So notice y equals mx plus b. The y-intercept is -2. And then that slope tells us to go up 2/3, and I have that line already drawn, so just like that. And then the next line tells us to start at 3 on the y-axis. The slope says to go up 7/3, but because that's off the graph, I'm going to go down 7 and back 3. So down 3, 4 more is 7, and over 3. And there's this line right here. And oh, look, let me get that so they overlap at this solution set. So that is -3 down to -4. So the x value is -3, the y value is -4. So when it's asking you to solve by graphing, this is all that it means. But there are a couple situations you need to be aware of. What happens if you didn't have these two equations in slope-intercept form, but you had it in standard form, and when you solved, they ended up being the exact same thing? Well, then this line right here would just set right on top of this line. Well, this is that situation right here. So when two lines sit right on top of each other, then look at, they share every single point. Let me choose a different color. Every point. And in between all those points that I just made, there's an infinite set of other points. So when two lines lay right on top of each other, you can see there's a blue line and red line. That's the solution set is infinite solutions, or all real numbers. And the system is called consistent and dependent. People who write tests sometimes like to ask that question. Okay, and then the next situation is when two lines, so if we would have had y is equal to 2/3 x plus 3, and y is equal to 2/3, whoops, I left off the x, minus 2. So if we would take this line right here and move it up like that, well, notice their slopes are the same. They're parallel. Parallel lines will never cross. So that solution set is no solutions. And if a system has no solutions, it's called inconsistent. Okay, that's it for solving systems by graphing.